This lesson today is, what is the design process? And you see up here that I have a bridge. As a matter of fact, I have 4 different types of bridge. I have a truss bridge, an arch bridge, a beam bridge, and a suspension bridge. You see, the design process is all about solving a problem and finding solutions. So, today's problem that we're going to use the design process is, we want to know how we can make a bridge stronger. A bridge stronger. Have you ever seen any bridges?
Yes.
Have you ever went across a bridge?
Oh, yes.
Oh, yeah. In a car?
I did on a field trip.
On a field trip. In the summertime, I take kids on science summer safari, and we go to a place called Turkey Run State Park, and we walk across a suspension bridge high above Sugar Creek, and we walk across it. The whole bridge swings and it kind of hangs. Okay? You can see that there are all types of bridges going across water, going across rivers and lakes, and the one at the very top is pretty amazing. There is one that looks like the Golden Gate Bridge, and this one here is like the London Bridge, and this one has triangles in it, and this one is like has cables, and this one, I love this one right here. Now, this one right here has arches in it. In fact, look at this last one right here. This one right here, and we can make that a little bit bigger maybe. That has arches, and an arch is a very old way to make a bridge. So that's one of the types of things we're going to look at. We're doing our research. We're doing research for our prototype. The arch bridge. The arch bridge is pretty simple. Go on down. There's another one. It tells how the forces are. And the arch is just kind of like an arch, like you might see at McDonald's. Next, this is a suspension bridge. It's being held up. The road is held up by cables. And the next bridge is, there's more suspension bridges held up by cables. The next one is called, go ahead, is called a beam bridge, a beam. And then the next one is called a truss. It has trusses or little triangles that help spread the force. And the last one is called a cable stayed. The cable stayed bridge is really kind of interesting. It's got all these cables on it. Okay, let me demonstrate those bridges. Okay, so the 5 types of, here's the first one. Put your hands up like this. And let's make an arch. Okay, lean in, push, lean in. And that's an arch. An arch bridge is kind of like that. And as long as, boy, push against me. Oh, this bridge is really strong. As long as we don't fall down this way. That's an arch bridge, okay? The next type of bridge is a suspension bridge, but it's like my belt holding up my pants. So a suspension has cables that hold up the bridge. Here's another type of bridge. Put your arm straight on my shoulder. There you go. This is a beam bridge, really strong. Oh, she's pretty strong. That's a beam bridge. See how it's like straight up in the beam? And then the final bridge are triangles. So I'll put one here, you put one on my head, and put one on my shoulder. See, here we go. There we go. Those are triangles, and that's a really strong bridge too. So there's a lot of different types of bridges, and your job is to make a bridge. Okay, so to build this bridge, you have a bunch of different materials. You can use all the materials to make your bridge. The number one rule is, these are going to be your supports, and they have to be 25 centimeters, not 25 inches, but 25 centimeters apart. And so that puts it right about there. And once you get it 25 centimeters apart, you can use all these materials to build a bridge. You cannot use the ruler, okay? Anything else. But once you build the bridge, I have 1,000 gram weight, and we'll put it on there and see. Oh my goodness. We have another 1,000 pound weight. So you're trying to make a strong bridge. And so after we build it, we have to test it. 3,000 grams, 3,000 grams. Uh-oh. So I know that my bridge failed at 3,000 grams. Your job is to make a bridge that's stronger to hold more than what?
3,000.
That's your challenge. Make a good prototype, be safe, and first of all, talk about your design. Don't just start building. Talk about your design. work together, then start building. Get busy, engineers.
That's probably the best of all. Cheater boss.
No, do that the other way because you're trying to put them together.
Hey, that's a great idea. Yeah. They can't fall down.
And if they fall down, they both fall down.
Yeah.
And if these fall down,
We're trying to test one of these. We're trying to put all of them right here and then put these and tape them. And then put them across all the way to here. And then we're going to test it to see if it works.
So as you can see in this design process, there's a lot of talking, there's a lot of discussions, and there's a lot of trial and error. And these students are doing a good job trying to make a bridge stronger using the design process. I can't wait to see the results and see how they test their bridges.